Hi, this is Kevin Trainer. It's the summer of 2019, and I am re-recording my tutorial on the final project assignment in my Python course. And I'm hoping this is going to have a fairly long life, at least a year. Why do I have to re-record it? Well, a couple things have changed, not very many. One is I'm now teaching the course at two universities. And so when I first began to teach this, I was teaching it only at UWM, but now I'm teaching it both UWM and Illinois. And so I needed to have the references to the programs make a little more sense. Okay. The next thing is I've made a couple of improvements over the last year in the approach that we take to creating custom Python classes. And I wanted to incorporate the material for that in my tutorial overview. So those are the only changes that I can think of. Um, so here goes. I want to begin by saying that the data that we are going to be analyzing in this assignment, this is uh, this assignment is kind of cast as a data science-like assignment. Um, what you'll be doing are skills like you've been doing on the coding assignments. But the whole assignment has an overall theme, and it's to clean and analyze some data that I got from the Wisconsin Department of Health Services. And it has to do with the population of Milwaukee County. So a couple of things. Uh, I had to pick some place for this to be about, and I first picked it to be about Milwaukee, and well, that's a that's a major U.S. Metropolitan area, and I think it makes sense to analyze these data, whether you're at UWM or you're at Illinois. So, but I do want to point out that the data divide the population into male and female. And apparently this was useful for the researchers in their work. But I just want to point out that I'm aware, and I think all of us should be aware, that many people today, especially in the university world, um, have have developed a much more nuanced gender identity or gender identity awareness. So they don't see this as a binary world where you're either male or female. And so I just want you to know that I picked this data set out of expediency, and I do have a lot of respect and support for everybody who has a more nuanced gender identity than this. I did put a link in uh, to the Wikipedia article on gender identity as a way of maybe getting people who um, were not um, aware of non-binary gender identities, maybe giving them a resource that they could use um, to get started in a fuller appreciation of gender identity. Okay, so that's all I'm going to say about that. Okay, so again, um, this is an assignment. This is an assignment that has 4 exercises in it. In that way, it's a lot like a lot of the coding assignments that we did for homework. Um, the differences are important though. Each assignment, each of the exercises is probably going to take you longer, okay? Because I- I've given you, when we were doing the homework assignments, I generally did a tutorial video in which I showed you code for a very similar program, and then you had to sort of adapt that and solve the problem that I gave you. In this case, I don't have those tutorial videos. The only tutorial for the final project is the one that you're playing right now. Okay? So I'm expecting you to be more independent in this final project than you were being in the coding assignments. On the other hand, I have provided in at least 3 of the 4 exercises more design guidance. Okay, I've provided in each case pseudocode for the solution. And pseudocode is something that we learned about in the course and we practiced a bit. And I tried to gear this assignment to be um, the the material I'm giving you is kind of like the specifications I would give to a junior person on my team. Okay, so I'm not giving you every detail of how to do it, but I'm being pretty clear about how the design should go. For senior people, people who've been through programming quite a bit, this is probably going to be more help than you need. And for more newbies, I'm hoping this is going to be just right. And the experience I've had with this, I've been using this final project for about a year now. And the experience I'm having with it is that it's turned out about just right. Okay. Okay. So that's the overall point of view. Um, the other thing is, depending upon which semester you're taking this course, uh, you might have either longer or shorter to get the work done. Okay, I teach this during the regular school year in typically a 16-week semester, in which case, we usually have a couple 3 weeks at the end to concentrate on getting the final project done. I do teach it in a 12-week summer semester, which is what we're doing right now. And it's tight, okay? So, especially if you're in the summer semester, and also if you're in a longer one, uh, you might want to think about doing the first half of the final project uh, early and waiting until you get the proper skills for the second half. Okay, the second half of uh, the final project, exercises 3 and 4, required that we had already covered the chapter on creating custom Python classes, which in the current version of the course, we cover that with chapter 14 from the Severance book. Okay. And that's one of the last things that we learn. Okay, so you have to wait till pretty much the end of the presentation of the content in the course to have all the skills that you need to do exercises 3 and 4. On the other hand, can you can do the first 2. Okay. once we get through chapter 8 of the Zell book. That's the chapter on looping. Okay. So what, especially if you're going to be tight on time, I'd like you to plan on starting the final project, the first two of the four exercises, right after we covered chapter 8, so that you can get that done. That's challenging enough all by itself. And then waiting until we cover chapter 14 of the Severance book, which right now is the last uh, of the content that we cover, to come back and do exercises 3 and 4. The good thing about that is that exercises 3 and 4 are a lot like the exercises that we do in the coding assignment for Severance chapter 14. So I think you'll be ready to do 3 and 4 because you'd be really primed up for that kind of work. Okay. Okay, so what are the things that we're doing? First of all, the data that we have here is from, it's population data from Milwaukee County from July 2014. And if we look at this, right now that's the most recent data that's available on that page. You don't have to download the table or view the table. What I did is I took the data and I turned it into files that you'll be able to read. That's the good news. Okay, but I just want you to know that's where this came from. Okay. So let's go down in here. I've got a bunch of stuff about the expectations. That's pretty similar to the expectation. It's an aggregation of the expectations that I set out for all the coding assignments. The starter files, okay. Um, you can download this from the weekly schedule entry for the final project assignment. I've changed the name of this. The name of the file used to reflect the course number in Milwaukee, and now it just has the words Python course in it. Okay. The two data files that are in the zip file, uh, they start off being identical. One's called raw data.txt. The other one is called cleaned data.txt. And in exercises 1 and 2, we're going to be doing data cleaning. Okay. Well, what data has to be cleaned? Well, being the rascal that I am, I took the data that didn't require cleaning from Milwaukee County and I seeded some data entry errors into it. Okay. So when you go to add up the data across the columns, it doesn't it doesn't add. When I say across the columns, I mean when you add the data for one row across, uh, some of the rows have errors. Likewise, when you add the columns down, some of the columns have errors. And this would be a good time for me to show you the data. They're down here. It's attached in Appendix A. Okay, so these are the real data. And the file that I've given you has been corrupted in some ways. So in exercise 1, you're going to be reading the file with these data, and you're going to be doing the calculation to make sure that the column totals are correct. And then when you get all those correct, then you're going to be working with exercise 2, and you're going to be writing a program to add down the columns to make sure that the total row is correct. Okay, and when you've done that, that'd be a typical thing that you would do to expose all the inconsistencies in the data. Now, could you could you take the file that I give you and open up into a text editor and simply correct these by proofreading them? Yeah, you could. Okay, but that kind of approach is not really feasible. Number one, it's not reliable because humans make errors even when they proofread. Two, um, if we were doing this to a lot of data sets, as we would be doing if we were doing this on the job, it wouldn't be feasible to do this only by proofreading. Okay, so you can try to do that, but the fact is you need to create the programs that that you have to hand in anyway, and they make it easier to detect these kind of problems and correct them on a scale that we would be using in our day jobs. Okay. Okay, so let's go up and look at exercise one. Okay, sorry about that. It's a long way up. Exercise one. Okay. Um, and you're going to be creating a program called Detect Row Level Data Entry Errors. Okay, so uh, where is the data? Well, I should probably pause this and then go get the data so we can see it. Be right back. Okay, we're back. And what I've done is I've taken the starter files for the Python course final project. I downloaded that zip file from the weekly schedule and I decompressed it and I've opened the directory. And there are two files here as the instructions promise, raw data.txt and clean data.txt. And if you look over at the statistics in the Finder here, you'll see the date modified on these files is the same, the size is the same, they're the same file. Okay, well, why is that? Well, that's because cleaned data.txt is, when we begin this, it's an aspirational name. Okay, it's not cleaned yet. It's the copy of the file where we're going to clean it. And so by the time we get done with exercise two, it will not only be an aspirational name for the file, it'll be a fully descriptive name for the file. Well, why did I give you raw data.txt? Well, this is in case uh, you have to back up and try again. Okay, if you get the data so twist it around that you want to start again, you can start again by taking the raw data file and copying it over top of the cleaned data file, and then going back and starting with exercise one. Okay. If you do it all perfectly and you don't ever want to back up, then you never have to touch the raw data.txt at all. Okay, so that's what they are. So let's look at cleaned data here. Okay, and I'm going to open it with TextMate, which is one of my favorite text editor programs on the Mac. So let me bring it over here. You can see it. And pretty much it's the data that we saw um, when we looked at the PDF that's, I'm sorry, that's at the very end of uh, the instructions. Okay. Thing is, this is a readable text file. So this is a plain old text file. uh, notice how it ends with an empty line, okay, which is just the line feed that's at the end of the one before it. So this is the typical kind of text file that we've been reading in this course, all right? And it, it, it has a category label. Um, at one point uh, in one point in my talking about this file, I refer to this age group category label as a label. At another point, I talk about it as the category. Well, it's a category label, so you could call it one or the other, so don't get confused. And of course, there's a total line, okay? And then the columns, we've got the male count, we've got the female count, we've got the total count, okay? And I have very judiciously seeded some errors in here such that not all the rows add across and not all the columns add down. Okay, so your job is going to be to create the program for exercise 1 and run it using these data. And then when you find an error, okay, how are you going to fix it? Well, you're going to identify the row that has an error by running the program from exercise 1. Okay, so exercise 1 is going to create row level data entry errors. And as you can see, in the beginning, you should have errors in 3 rows. Okay, so I've shown you what the output is supposed to look like. And if you're not getting these answers, then you have some kind of a math problem. Okay, so these are the answers that you should be getting, and the formatting that we see here, including the blank lines and what's in what column and the center title. These are all things that are important when I'm going to be doing the grading. So you're going to have to fix 3 rows at this point. And how are you going to do it? Well, you're going to compare the values on the row to the uncorrupted data in Appendix A right here. Okay, and you're just going to correct the values. So you're going to correct a line. How are you going to correct a line? Well, you're going to go to the editor and you're going to actually change the values in the editor. And then when you run the program again, right? Well, the answer for the report is going to, sorry, this is a long way up. The answer for the report is going to show that we have corrected the error on that line. So then you'll go to the next line, and then you'll go to the next line that has an error. So when you get finished and you run the report, it should look like this. This is when you've come to the end of exercise 1. You don't have anything in the error column. Okay? So how are you going to do this? Well, it's a lot like some of the report programs we've done already. I've given you pseudocode. Okay? And the code for exercise 1 is pretty straightforward because we are adding across the rows. So this should work for all the lines in the file, including the total line. They should all add across and give you a 0 error. Okay, so that's exercise 1. What are we going to do on exercise 2? Well, exercise 2 are we're going to create the program detect column level data entry errors. Okay, and so if you add the columns down, once you get the rows to add across, Then you want the columns to add down. Okay. So what do we mean for the columns to add down? Well, nothing for the category label. Okay. But for the column that holds the mail count, we want to make sure that when we add the mail count for all of the categories down through 85 plus, that they equal the amount that we have on the total line. Okay. And the same for females and the same for total. Now they don't because I I goofed up the numbers. Okay. And are numbers goofed up in the real world? Yeah, they are. Generally, what can go wrong will go wrong. So if somebody did the data entry on this for you, they could have easily made some typos that led to the errors that we see uh, here. Now, the answers that you see on the current version of the report were column one is short by 100. The females are long by 600, and the total is long by 500. These are the answers that you should get when you've made the row corrections already. Okay, so if you decided to do exercise 2 program first and you ran it, you'd get different answers. Okay, so you want to correct the rows first. So these are all zeros. And then when you write exercise 2, when you write the program and you run it, these are the answers that you should get before you make any of the changes. Um, the thing that is challenging about exercise 2 is that we are accumulating these down the columns as we read the records. Okay, now one of the real nice things about these uh, the work that we were doing in exercise 1 is that we are uh, we read things a row at a time and we analyze them a row at a time. Okay, but the fact is that with exercise 2, we have to read all these, we have to read and print all these lines, and it's only when we get down to the total line that we're able to do the analysis that leads to what we put on the error line. Okay, so we're going to be doing a lot of reading and printing and accumulating all the way down. When we get to the total line, well, we've got to print the total line, but then we have to take the amount that we've accumulated for all the lines but the total line and compare it to the amount that's on the total line, and that's how we get the error. Okay, so it's a little more challenging to do it down the columns and across the rows. Okay, I don't think we've done anything exactly like this, but I believe you're up to it. Okay. When we get done, again, how are you going to fix this? Well, you're going to go to Appendix A at the end of the instructions, and you're going to look at the original data, and then you're going to compare them to the entries that you have in your data, and you're going to find the values that are wrong, which could be in any of the rows, and you're going to fix them. Column 1, fix column 2, fix column 3. Okay, so when you're done, they should all be 0. So when you have the data all cleaned and saved, you can go back and run the program from exercise 1. You'll get all zeros down the rows, and you can run the program from exercise 2, and you've got all zeros across the columns, and you are done. You have clean data. So now the name of the file clean data.txt is truly descriptive. It's not aspirational anymore, because that's really what's in it after you get done with exercise 2. All right. Now, to do this, you only have to have gone through Zell Chapter 8, okay, which in the current semester we just covered last night. And so you should be able to get started anytime after that. Okay. Um, I give you some hints, okay? I give you some hints on I think really all 4 of the exercises, but I say for instance, how wide the report is and how wide each of the columns are, and that we want to center the title in a column that wide. I give you the format string to center a title in a column that wide. And then I give you a format string that you could use to create the kind of uh, comma delimited, the kind of values that are right justified, have the commas in the proper place, and all of that stuff. Okay, so I haven't given you all the code for the line that prints with formatting, but there's enough information here that you should be okay. So that's where you are at the end of exercise 2. Exercise 3 is not really doable until we've covered the module on custom Python classes. Okay, and again, the text that we're using for that right now is chapter 14 of the Severance book. Okay, and the work that we're going to do in exercise 3 and exercise 4 are pretty much the same things that we're doing for different kinds of data in the coding assignment that we're doing for Severance at chapter 14. So when you start this, you should have just successfully finished Severance chapter 14, and so you should be pretty well geared up to do what you have to do. Okay. In exercise 3, we're creating a custom Python class that holds a row of data facts about one of these population categories. Okay, and so you can see that it's called the class is called population group. The instance variables are category, male count, female count, and then typically we don't store things that we're able to calculate. So even though our input file uh, had the row total in the data, we're not going to store that when we store this. What we're going to do is we're going to have, again, 3 instance variables, and then we're going to have a method that calculates the total count. Okay, so you don't have to calculate it yourself, but you haven't stored it explicitly. You can call the method calculate a total count in order to get it. Now, I want to point out that the names of the instance variables, and the name of the method and the name of the class should be exactly what we say here. We want to be able to share this. We want to be able to share this custom class with our coworkers. Okay, and so they need to be able to expect exactly what the class is going to be called, what each of the instance variables is going to be called, and what all the methods are going to be called. So you don't want something close to the names here. You want these exact names. Okay. And what we want you to do is we want you to create what in the work that we do for the severance chapter 14 chapter. It's what we called the evolved version of the class. This is going to have all the bells and whistles on it. We're not going to do a simple version and then upgrade it. We're going to go right to the final product. So when we're doing that, we have a job aid that we gave out during the work we did with Severance Chapter 14. It's a cheat sheet on how to create a custom Python class. So it goes through all of the different steps in the proper order. Um, it even gives you hints about where to put the unit test cases um, and how to formulate them. Okay, so again, by the time you're doing exercise 3 here, you should be coming off an assignment where you just used the cheat sheet. Okay, so you should be in pretty good shape. Okay. Um, in addition to these property-based getter-setter pairs, uh, we are expecting to have um, methods. So we're expecting to have an init, which is the constructor. We're expecting to have a string, str, and we're expecting to have a repr, representation. Okay, so you need all these things. These are the same kind of things that we just did for um, Severance Chapter 14. Okay, all right. So when we're done, we have a class that can hold values for these categories. Okay, it holds a sort of a line full of data from the original test data. Okay, and so now we're going to come down to number 4, and we're finally going to write a data analysis report. So it's called create data analysis reports. Okay, and this is very similar to a kind of a report that you will have created for Severance Chapter 4, where you use the custom class as a data holder and you're able to put all the input data into a list and you're able to sort it and then you're able to iterate over the sorted list and generate the reports. Okay, so what's different here? Well, one, there are two kinds of reports. Okay, so one kind of report we already have experience with. These are reports of counts. Okay, and they're organized by age group. Okay, okay, that's pretty much the way that the data was presented um, in our earlier processing. So we sort them by age group, and then we run the counts. Okay. The other thing that we have is that we have these percentages. Okay. Now the percentages, this is the first time that we're dealing with this in the course. So you got to be a little bit thoughtful about what's going on. But if you go back here to um, the counts, remember the counts, they add across the rows and they add down the columns. Okay. Now, is that true for the percentages as well? No. Okay. It's the nature of percentages that they don't add across the row. Okay. What you get in the total column for a particular row is more like the average of the males and the females. Okay. But they do add down the columns. So when you add down the columns, they should all add to 100%. Okay. So uh, I give you pseudocode for all this. Okay. So here's the pseudocode for the main. Okay. And when I'm expecting you to call or invoke lower level code, some function, uh, I use the word do. That's the pseudocode word people typically use for call. Okay. Um, and there are two kinds of reports. So you have a function to build each of those. Uh, one is um, uh, create a count-based report, and the other one is create percentage-based report. Okay. Uh, the other thing that you do in the beginning is, of course, you have to build the population group list from the input file. And one of the things that is a little bit hard for some people to understand is that we don't store totals. Okay, generally speaking, in data stores like relational databases, which we're kind of simulating here, uh, uh, we don't have a total row. Okay, well, how do we get the total? Well, we calculate it every time we want it. Likewise, we're not storing a total field in each of these objects that we're storing. Um, we're storing the male count and we're storing the female count. And when we want to get the total count, we call the method that adds the male count and the female count together, and we get it in a very convenient way, but it hasn't been stored. Okay, it's implicit, so we calculate it. So one of the things that we need to do for these total-based reports is that we need to calculate the column totals. Okay, so we need to do that one time. They're not going to change no matter how you sort these. Okay, the column totals are always going to be the same. The rows are going to be in different orders, but it's not going to change the column totals. So you're going to want to build your list once. You're going to want to calculate your column totals once, and then you're going to want to sort the list. Okay. Run the count-based report. Run the percentage-based report. Sort the list again, and then again, and then again. Now, this results in the reports being interleaved. Count-based, percentage-based, count-based, percentage-based. Why do we do that? Well, because we don't want to sort the report 8 times. We don't want to sort the list 8 times. This could be a big list in some applications, and so sorting it could be pretty expensive to do. It could take a lot of processing time. So what we want to do is we want to do it only 4 times. Okay. We've got some pseudocode here for every part of it. Okay. It's vague enough that you're going to have to work. Okay. It's pretty much similar to the work that you'll have just done for Severance Chapter 14. Okay, and we've got hints about formatting strings and all of that kind of stuff. Now, the one thing to remember when you're doing the work here is you don't have to do everything at once. Okay, so my recommendation is to write the code for the count-based report. Okay, and get it to work for the first group, the counts by age group. Okay, and once you get that working, then to do the sorts and run um, um, the counts by descending total count, the counts by descending female count, the counts by descending male count. Get all the counts reports to work. Get the first one to work, then get all the rest of them to work. And then turn around and then get the first percentage one to work. And then get the rest of the percentages to work. Okay, that would be a good strategy for how to do the programming and the testing. Okay. Um, with with all of the programs that process a file here in the final project, I want you to make sure that I want you to make sure that if the input file was empty, that you would make a graceful exit from the program. Okay, that's something that we've been doing since chapter 5 of the Zell book, and that's something that we want to keep doing. I think that's it. Okay, so if you think of this as best done in two parts, um, the part that you don't have to know about custom classes to get done and you can start working on after Zell Chapter 8. That's going to be helpful. And then when we finish Severance Chapter 14, you should be really geared up to do 3 and 4. They're very similar to what you'll have done in the coding exercises for the Severance Chapter 14 assignment. Okay, so that's it. Good luck on this. The one thing I wanted to add on here, I nearly forgot, is the same kind of help is available for the final project as you've been getting for the coding assignments. So when we have any kind of lab sessions, the one that we have at the end of our normal class, or the one that we have later in the week, you you should be able to come and get help and ask questions. And it's okay for the people to help their classmates. Okay. What I typically say is if somebody's having a hard time and they want to show the code that doesn't work to a classmate or to me, that's great. And then what we should be willing to give them are our ideas or maybe code snippets to get them out of trouble. Okay. What we don't want to give them is a big part of our working code. We want to coach them to create their own code that works. Okay? But you certainly are able to help each other, and I'm available to help you. So please take advantage of all of that. Okay, that's it for me. Sorry to be so long-winded, but hopefully this will be helpful. Good luck on the final project. I'll see you next time. Bye-bye.